In MCQ 15, this is a question with regards to acid-base equilibria or ionic equilibria. So reading on the question itself, this requires us to have an indicator that stays on at a pH roughly of around 10. So any kind of solution that wants to have its pH being undeterred by the addition of different samples to it will have to employ a buffer. And on top of that, the pH that is desired for this indicator to stay is at that of 10. So we should be using what we call as a basic buffer instead. So prior to looking at the options that's available to us, let's take a look at what are the contents of a basic buffer. Now, firstly, you will need a weak base, which is going to act as a proton acceptor. On top of that, there should have also been a conjugate acid, which can act as a proton donor. Now, why they can actually manifest buffering capabilities, because if let's say excess proton was added to the solution, it will react with the weak base in the basic buffer so that the H+ could not have altered the pH of the solution. But for the case of adding excess hydroxide, the conjugate acid will donate a proton to react with the hydroxide to form water, which also does not cause any change in pH to the solution. So investigating each of the options here, for A, we have ammonia, which is considered to be a weak base. We also have ammonium chloride, which is the conjugate acid of this weak base, which can be formed by taking excess ammonia to react with limited HCl. So A is the correct answer over here for the case of the basic buffer. But let's take a look at the rest of the option to see why it's actually incorrect. For the case of B, we do have ammonia again, which is the weak base. But this time around, it's not paired with a conjugate acid, but rather is paired with sodium hydroxide, which is considered to be a strong alkali or a strong base. For the case of C, we have sodium hydroxide, a strong base again, but this was actually paired with sodium ethanoate. Now, sodium ethanoate is considered to be the conjugate base that comes from the reaction of ethanoic acid reacting with sodium hydroxide. So this conjugate base itself is more towards the extent of using it as part of an acidic buffer rather than as a basic buffer. And since the question wanted the pH to be regulated at roughly around 10, an acidic buffer cannot do so because acidic buffer will have a regulated pH for a solution that wants to be below that of 7. Now for the case of D, we're looking at just sodium hydroxide only. This is not going to be useful at all because as a strong base, it does not have any buffering capability. So the correct answer here again, just to reiterate, is going to be A.